My name is Ian Bromley and I'm an Applications Engineer here at Element 14. Today I'd like to welcome you all to an exciting new product from the Atmel product range that we stock. This is basically the new Xplained Pro Series kit based for the ATSAMA5D3, which is essentially an ARM A5 core. The evaluation kit that we offer today offers you, the engineer, a range of features, 536 MHz of performance, but at the same time, with the low power modes offering you 0.5 milliwatts, meaning that this board can lend itself very well to a number of applications. In terms of connectivity, we can offer you Ethernet, gigabit Ethernet, USB on the go. We can offer you camera interfaces, display interfaces. On board we have NAND flash and eMMC flash, basically where we can store the Linux kernel, which means that essentially as an engineer you have the hardware, the software and the firmware to immediately get started with this kit. In terms of where we see this fitting, certainly into industrial control applications where a high level of performance and connectivity is required, and potentially like HMI type applications. When we think about the low power mode performance of this device, then we see it equally fitting well into things like wearable computing and possible applications of that nature. Today, what we hope to do with the demonstration is we're going to show you the actual evaluation board itself and the USB cable, which is essentially what you have in the kit, which is all you need to get started. Here you'll see we have an additional modules that are also available, the 4.3 LCD panel, which is touchscreen. We also have Wi-Fi connectivity in terms of the small Wi-Fi module, and here we have an example of a 1.3 megapixel camera that can be simply connected via USB to this board. So let's take a closer look at the board itself now. So to start with, when we look at the board, we can see centered in the board the Atmel A5 core. This is the heart of the product. Supporting that, we see that you have 2 GB of NAND flash and 2 GB of eMMC. This is essentially where you can load the Linux kernel, which helps you to automatically boot the board. Moving around the board, we also have here, you can see the connectivity where we have USB, both host and on the go, in addition to Ethernet, 100 base T and 1000 bit T or gigabit Ethernet. In addition to this on the board, we can see the camera's interface and also the display interface to go out to the LCDs. In addition to this, you can see the 20-pin JTAG header. We have a couple of push buttons and user LEDs, just for simple indication. When we look at the I/O, a lot of you may remember this format is looking very compatible for the R3 Arduino Shields, which for a number of these boards is okay. When we just finally look to the back of the board then, what we simply see here is we have a simple SD card reader, which for the purpose of today's demonstration is where we take the demonstration code from. Okay, now let's get to the fun bit and do the actual demonstration of the board. So for the purpose of the demonstration today, we're just going to simply use the evaluation kit and the display module. These modules can be used at a later date, but for now we're going to just use this with the USB lead. So firstly, we have to just simply connect the FPC cable into the actual evaluation kit. Okay, and I'll just turn this around so you can see this better. Now we need to apply some power to the board, again done by small USB just here, and then we connect to the laptop for power. Now as mentioned, the only reason for connecting to the laptop is for power. All the hardware, software and firmware code is installed within the board itself and the SD card. So now when we power the board up, what we should see is a blue LED indicating that we have a power connection, and within a couple of seconds we should see the screen light up. The flashing LED is just indicating booting of the code, and there we go. Okay, so now when we look at this, we have a number of applications to demonstrate. Again, we're going to look here simply at the touchscreen capability. So by simply touching the screen, we instantly get into an application here. Here at the side of the screen we can see there are some capacitive touch sense buttons as well that can be user configured. So for instance, this application here that we're looking at, if we're pressing this, we have a simple calendar application. So by simply, if you were to add a keyboard to this, you will be able to put calendar entries into potentially an application like this. Okay.
So coming into here as well, we have some other things like internet browser. We also have a contents for your fridge.
So I don't know if you're like me, but sometimes I'm quite good at forgetting to buy the milk the day before.
And if I had something like this applied to my fridge, if you can imagine in the front panel, you would be able to instantly check by looking here at what you had in your fridge and apply a shopping list. Then just by simply going to here, you can automatically start to get these things, those careful reminders that you need to do. But if you imagine this as an application embedded either with Ethernet or for Wi-Fi capability, you start to get a feel for how powerful this product is in these kind of applications. A nice little feature I saw in here, that it can also look at what you have in your fridge and pick out a few items and ask it to find you a recipe.
It would then go to the internet and come up with suggested products for you.
In terms of what else we have on this board for the demonstration, we can demonstrate here the board's ability to be able to represent HTML files reproduce, and here we have a simple Atmel image provided on the board itself. And again, just by simply quitting, you saw the browser window there. Again, we don't have internet connectivity today, but what we do have here is an example of the browser that's built into this particular software. When we look at other things about what the board has itself, we have a couple of little games here which really demonstrates the graphic capabilities and the touchscreen. Simple things like this. Okay. So, in terms of extra things on this board now, as you can see, I think the possibilities are quite wide. So, in conclusion, I hope what I've been able to show you today is some of the key features of the new ATSAMA5D3 evaluation board with its host of connectivity and peripheral features, in addition to a live demonstration there. I think what you can see here as well from the embedded support that you get from the Open Linux Society in terms of the Linux kernel and the demonstration code from places like Linux for Sam really can offer you, the engineer, the equipment and the facilities to rapidly realise your next industrial control application with ease and confidence. Thank you very much again for joining me today, and please, for more information, do see element14.com. Thank you.